It was moving at over 100,000 miles per hour. Its trajectory was impossible. It did not belong here. This is the story of 3I Atlas, the third confirmed object to enter our solar system from interstellar space. It is a piece of rock and ice that formed around a star billions of years ago, a star that is not our Sun. For a brief but a critical moment, this ancient traveler came within 270 million kilometers of Earth. That was close enough for our most powerful telescopes and deep space probes to capture its secrets. What did we learn from the closest flyby of 3I Atlas, which is older than our own planet? The data is in, and the findings change everything we thought we knew about the chemistry of the cosmos. This is not the first time an interstellar visitor has graced our skies. The first, Oumuamua, was a mystery, a strange, tumbling object that defied easy classification. The second, 2I Borisov, was a clear comet, a familiar form with an unfamiliar origin. But 3I Atlas, the third confirmed interstellar object, offered us something neither of the others could: a rare, close-up look at a piece of another star system, a window into the chemistry of a distant stellar birth. In the coming minutes, we will trace the journey of this cosmic wanderer. We will explore its discovery by the Atlas Survey, the Asteroid Terrestrial Impact Last Alert System, and understand why its trajectory proved it was not bound to our Sun. We will delve into the data collected by our most advanced instruments, from Earth-based telescopes to deep space probes like the Parker Solar Probe and the Europa Clipper. We will uncover the object's true nature. A comet, yes, but one that is potentially 7.6 billion years old, making it one of the most ancient, pristine relics ever studied. This is the story of how humanity reached out across the stars, not with a spacecraft, but with a telescope, and what the universe whispered back. The story of 3I Atlas begins not with a flash, but with a faint smudge of light on a digital sensor. In late 2024, the Atlas Survey, a network of robotic telescopes designed to spot potentially hazardous near-Earth objects, flagged a new visitor. Initially, it was just another comet, designated C/2024 Atlas. However, its velocity and trajectory astounded researchers. Every object in our solar system, planets, asteroids, comets, follows an elliptical path, a closed loop, bound by the Sun's gravity. But 3I Atlas was moving too fast. Its trajectory was hyperbolic. It was moving too fast to be caught by our Sun's gravity, proving it was on a one-way ticket out of our solar system. It was not a resident. It was a transient. This is the moment it earned its I designation: Interstellar. The closest approach to Earth occurred on December 19, 2025, at a distance of approximately 270 million kilometers. To put that into perspective, that is about 700 times the distance to the Moon. It was never a threat, but it was a perfect opportunity. The classification itself was a scientific triumph. Dr. Michelle Bannister, an astronomer specializing in small bodies, noted that the very existence of these objects confirms a long-held theory that the galaxy is littered with the debris of planetary formation ejected from their home systems. It was a comet. It was composed of ice, dust, and rock. But the question remained: what kind of ice? What kind of dust? The answers would be found in the tail it left behind. A comet is a time capsule. As it approaches a star, the heat causes its frozen materials to sublimate, creating a glowing cloud called a coma and a long, streaming tail. This tail is the comet's fingerprint, a chemical signature of its birthplace. Astronomers, using powerful instruments like the Keck Observatory in Hawaii and the Very Large Telescope in Chile immediately turned their spectrographs toward 3I Atlas. They were looking for the telltale signs of molecules like cyanogen, carbon monoxide, and water. What they found was a composition that was surprisingly familiar, yet subtly alien. The chemical mix inside it, especially the amount of frozen carbon monoxide, was very different from our own comets. This suggested that 3I Atlas formed in a much colder region, perhaps in the deep, dark reaches of a different star system, or was thrown out very early in its history. This is where the stakes begin to rise. The study of 3I Atlas is not just about a single rock, it is about galactic archaeology. Every atom in that tale was forged in a star other than our Sun. The object's estimated age of 7.6 billion years is staggering. Our own solar system is about 4.6 billion years old. This means 3I Atlas was already a seasoned traveler, billions of years old, when our Earth was still a molten ball. It is a relic from a previous generation of stars, a piece of cosmic history older than our entire neighborhood. The data from 3I Atlas is a direct challenge to our models of planet formation. It suggests that the process of forming and ejecting icy bodies is a universal, highly efficient mechanism, one that has been operating across the galaxy for eons. It confirms that the space between stars is not empty, but a vast, slow-moving river of ancient debris. The closest flyby was a moment of intense, coordinated observation. While 270 million kilometers is a vast distance, it was close enough for our deep space fleet to play a crucial role. The most valuable data came from instruments already positioned far from Earth. Take the Parker Solar Probe. Designed to study the Sun, its wide-field imagers were perfectly positioned to capture 3I Atlas as it passed through the inner solar system. The probe provided unprecedented data on the interaction between the comet's coma and the solar wind, the stream of charged particles constantly flowing from our Sun. The Parker data showed a very clean, well-formed cloud of gas and dust around it, suggesting that the object had not been significantly altered by its long journey. The dust particles it shed were analyzed by the probe's instruments, giving scientists a direct measurement of the material's density and size distribution. This was the first time we had been able to sample the dust of an interstellar object in situ, even from a distance. But perhaps the most intriguing observation came from the Europa Clipper, a spacecraft on its way to Jupiter. On November 6, 2025, the Clipper's wide-angle camera captured images of 3I Atlas from a distance of 164 million kilometers. This was a critical moment, as the Clipper's instruments are optimized for icy bodies. The Clipper's observations focused on the object's rotation and its nucleus. The data suggested that the nucleus was darker than expected, perhaps coated in a layer of complex organic molecules, the very building blocks of life. This is a common feature of comets, but to find it on an object from another star system raises a profound question. Are the chemical precursors to life universal? The scientific community, including researchers like Dr. Avi Loeb from Harvard, who has long championed the study of interstellar objects, used the flyby to push for a new era of space exploration. The idea is simple. If these objects are common, we should be ready to intercept them. The closest flyby of 3I Atlas was not just a viewing opportunity, it was a test of our global astronomical network. The coordinated effort, involving dozens of telescopes and multiple space agencies, proved that humanity is ready to study these fleeting visitors. The data gathered is so rich that it will take years to fully process, but the initial findings are clear. The chemistry of star systems across the galaxy is remarkably similar. We are all, in a sense, made of the same cosmic ingredients. But, As 3I Atlas now accelerates away, destined to leave our solar system forever, it leaves us with a question that is both scientific and deeply philosophical. We have seen its composition, measured its speed, and estimated its age. We know it was born in a distant star system, perhaps one that has long since died. But the ultimate question remains unanswered. Where did it come from? Was it ejected from a binary star system? Was it a rogue planetesimal from a red dwarf? Or was it, as some theories suggest, a piece of a shattered world, carrying with it the potential remnants of a failed biosphere? 3I Atlas has passed us by, but the journey to find its true home has just begun. The flyby of 3I Atlas was a fleeting cosmic handshake. But in that brief moment, it revealed three truths. First, our galaxy is alive, constantly exchanging material. Interstellar visitors aren't anomalies, they are the norm. Second, the universe shares a single recipe. The chemistry of distant stars is the same as our own. And finally, it proved our ingenuity. We united global technology to catch a ghost moving at breakneck speeds. 3I Atlas is gone, but the lesson remains. We are not an island. We are part of a vast interconnected neighborhood. And the next messenger? It's already on its way.